Hello and welcome to another episode of the RPS screencasts in the Learn Clang user group. RPS, Rock, Paper, Scissors, a simple game that shall help us to solve, that simple problem with the use of the C language. Last time we've been doing some work with pointers. Pointers, character pointers, obviously, so that we understood how they work, what kind of specialty they have. Remember, they end with a 0. And we kind of reorganized the entire program to use different compile units, namely RPS.c and main.c. So RPS.c contains the game engine, whereas main.c is using whatever functionality the game engine exports in order to, be the user interface or to implement the user interface of the game engine. So in theory, we're not really bound anymore to the command line. We could also have a graphical user interface and use the same implementation, namely RPS match. Today, we want to make it even more, even fancier. I'd say is not necessary, but on the other hand, we need to have a reason to get a bit more, to learn a bit more about C, namely how to use structures and what structures are, and we're going to redo the RPS engine to use structures instead. And maybe possibly we will do some heap usage. We will maybe allocate one of these structure on the heap and see where we go with that. Maybe, possibly, probably. Let's see. So last time we just ran our main engine, our game engine's main function, RPS match, and there's a switch case that basically just prints out whatever message we have to print depending on the respective output. We didn't do anything fancy here. I mean, previously the messages were nicer. Right now they are not. And I'm going to save the time to make the messages nice, because that's really nothing that we wouldn't know how to do, right? Some printf, some formatting here. It's as easy as that. So let's get into the structure game. So first of all, what would I want to use structures for? Well, that's a bit difficult because right now, the program is nice and simple and is exactly what it needs to be. So putting some more complexity in there is kind of feels a bit awkward. But what we could do is to try to think of our items here, rock, paper, and scissors, as objects. If you want to do some object-oriented programming, that's probably kind of the thinking that you want to apply here. Even though it's overkill, we just do it. So what we want to have is an item that represents a rock, paper, and scissors, and an item that possibly implements the logic of the respective game item. So what kind of logic do we have? We just have the I beat you logic. So we could say rock beats paper and then it returns true, or paper beats, it returns false, and paper beats rock and then it returns true. Something like this is something we could implement. So let's try that. First of all, let's have a new structure that will carry the data of our objects. And we will define it in our header. We will declare it in our header. I try to get the names right. And if I'm not mistaken, the code to do a structure is typedef struct, then the items of the structure, and then the name of the structure. RPS Item, let's call it like this. Right now we have an empty structure. And I'm asking myself what kind of fields I want to have. I think it starts with the name of the structure. Yeah, actually let's make it like this. Let's keep it nice and simple. So that's the name of the object. That would be rock or paper or scissors maybe. And then, well, what about an ID? Yeah, do I want an ID? Do I need some sort of integer ID that represents it, that I don't have to compare character pointers, even though I could compare character pointers? No, let's not use an ID here. Let's try to think of the interface. And well, you know, let's keep it simple. I could use, I could try to be some sort of pseudo object oriented and use function pointers here that I will assign to the individual things, so that based on the RPS item that I have, the algorithm to determine if it's success or failure will change. I could do that, but on the other hand, I could do it a bit more C style and say, why not re-implement RPS match so that it in fact uses an RPS item? Because these pics have previously been character pointers, which is kind of dependent on our user interface. And this is something that you shouldn't do. You shouldn't make the user interface define your API. The API should be, kind of low level, and the user interface just works with that library functionality. And right now, they because of our convenience, we just said, well, let's use constant character pointers, even though that's not really what you would do. So in a real game engine, you probably you have some sort of game item that you provide here. And because I just want to say, because quick acute creator is smart, it actually allows you to or it actually tells you that the signature changed and whether I want to change the definition around as well. So what does it tell me here? What's the problem? What's the issue? Yeah, I would just follow the symbol. I would just go there. Oh yeah, it can't go there because it kind of lost track of it, maybe. Yeah. There was a way to kind of make it realize or make me ask again whether I want to adjust these, but there was a hotkey for this. But right now, I don't see it. Add definition to rps.c. Yeah, see, so kind of it lost track of the existing definition that is here, actually. All right, let's just put it there again. And we are fine. Now we have to think of main.c, because main.c previously just provided us with the character name or with the names of the respective thing, and now we would need to have some sort of conversion function. We could implement this here actually, or we can also implement it in rps.c, or let's say in the game engine itself. We could have a function that actually returns an RPS item. And I don't want this item to be changed because right now it just has a pointer here and or a name and nothing else, and I don't see a point in allowing the user to change it, especially because I plan to pre-allocate these objects, because we will not have a dynamic amount of objects. We just have exactly three, and we know that in advance, so we don't need to use the heap to dynamically allocate these objects. Therefore, we keep it read-only. So we are going to return pointers to these objects because we don't want them to be copied around. We just want to point to them. We could also make a copy. I mean, this structure here has the size of 1 character pointer. So regarding the cost, we wouldn't care. But using pointers to a statically located list of items can help us actually when implementing things, possibly. So now we keep it as simple as we can before we think of how to use the heap in that game. And really, I don't know yet. Okay, so RPS item by name. So we provided with a name, and we expect it to return the respective item. So this brings us back. I mean, I'll just add the definition to rps.c. Thank you. That saves me some time. And now, instead of having the choices here, I might just want to have a list of items. And then we have to refactor a few of these functions here, because right now input ID is the thing that we that compares the string choices here with a given input, and then returns the ID of the choice, right? And now we don't return an ID of the choice anymore, but a pointer to the actual item. So this is the code we want to use down here with a few alterations. But first of all, we need an array of choices. So how do we do this? RPS item. We keep the actual RPS item. I was kind of tempted to put a pointer here just because I was kind of writing what I saw a line earlier, but the pointer is kind of implied because we have items, an items array, and we know that an items array is just a pointer to the first byte of the first member of the respective item. And we want to initialize it right away with the 3 items that we know, which namely is rock and I think I'm messing this up. I think I don't have the syntax. I don't get the syntax right because it's complaining already. See that? It's complaining for a reason, probably for a very good reason. So let's see what it says. Maybe I should put one of these here. All right. And as you can see, I mean, I will try to build this right now to see if it really is working. But as you can see, it's really rough. Rough in the sense of I don't use something like name equals rock. I can't do that, at least not right now, which means that it's really about the order of members in my struct that matters. So if I change the order, all of a sudden my initialization here goes totally wrong, and the compiler would usually complain, but depending on what you really do there, maybe the compiler can't tell if you really meant it or not. So I'm just saying, now I'm really dependent on the order of my structure there. But that's how you initialize a structure. It's really just curly braces, and then you add the individual items there. I think I've seen that in C you can also have a fancy structure initialization that allows you to kind of name the structure, name the fields of the structure when providing a name. And I'm just going to look this up. C structure initialization. In ANSI C. Yeah, so that's what I meant. It's kind of very rough, but I'd like to. That's how it goes. See? So C99, and I like to do it that way because it's a bit more readable. Let's try that. So it's dot name. Wait, equals, equals. Yeah, sorry, I'm kind of thinking of Python here. That's much better because now I'm not dependent on the order of my structure items anymore, and I tell the compiler what I really want, so the compiler can check, you know. And that's really it. So that's our initialization of the static list of items. I call it static because it's statically typed here in our rps.c compile unit, which means it will exist in the binary of our file exactly as is, and it will be marked as read-only, right? We are not going to change these at runtime at all. So let's have a look at the new function here, RPS item by name, right? So we go through here, num choices. I mean, the choices, I use them in a few locations, but I don't really want them. No. So let's rename this. It's now called num items. Num items, replace all. And here, of course, we have items and items. See, it's the same thing. Nothing changed there. Always the same way. And let's just look for, yeah, we'll have to change this a bit. Choices are valid. This will not happen anymore. This is something we will not need anymore. Let's kill it, because we kind of check our input pointers. So, but first of all, let's finish re-implementing this, right? Let's not skip ahead too much. So here I just go by ID, right? And now what I want is to actually return the pointer to the RPS item. And if I don't find it, I return 0. 0 always indicates that there is no, that this pointer is invalid, right? You can always compare pointers to 0, and if it is 0, you better not use it, because it's not pointing to anything. This also means that, you know, we could keep it like this, but we could also use a pointer to iterate over our list here. And how would that work? So first of all, we have constant RPS item pointer, which is the item itself. We initialize it. Does that work? Constant RPS item, yeah, that does work. We initialize it with our items array. That's the first member of, or the pointer to the first member of our items, right? And we just assign it to a pointer that we can change. And then we want that pointer to stay smaller than our items array, or then a pointer to one member past the last valid member of the items array. So that's the first member of the items array plus the size of the actual items array, which is +3. And this points to one past the last valid member, always. Num items. And then, last but not least, we just want to increment our items pointer. We use a prefix increment as usual, because postfix makes no sense here. And this kind of stays the same. So if I dereference my pointer here, I could do it like this, right? Then I dereference the pointer and point to an actual RPS item. But what I want is, I mean, no, that's what I want, but a nicer way to dereference something, let's call it item, is by using the dereference operator. So that dereferences the item and accesses a member of the structure underneath. So this is exactly the same as this, right? So that's the same, but honestly, that's much nicer to write, because you don't have to do the asterisk thing and the parentheses. So this is what you always do in C and C++. You dereference a pointer if it points to a structure or a class in case of C++, and put it here. And yeah, we compare this to the name, and if it matches, then we return the pointer. And there we go. That's our new implementation of RPS item by name. So now, now we all we have to do is to call this new RPS item by name function and pass in our arguments. RPS item by name. Pass in the first argument. It can return 0, right? RPS item by name if the argument is wrong, or if it's not none of the known items, it can return 0, but it's okay because RPS match will do as every good function will do and check its inputs. So we do not have to adjust the return values or the enumeration at all, because player 1 can still be invalid, player 2 can still be invalid. Which means that one of these pointer will be zero. Let's go back here. Oh, I don't know why. He actually doesn't like this. Well, who cares? Let's go back to our RPS match implementation and re-implement this to be what we need it to be. So if P1 pick is 0, we return RPS P1 invalid, right? Same thing for P2. If P2 pick is 0, then RPS P2 is invalid. All right. And that's pretty much it. So RPS error is something I don't return anymore because it makes no sense here. Because now these things have to be invalid. All right, I have to be valid once we are here. And now the question would be, how do we get the choice computation right? So we still kind of encoded with numbers here, rock, paper, scissors. So probably we wanted to have an ID so that we can do the math on it. It will make it much simpler, huh? Yeah, let's do that. No, wait. No, actually we can do that. It's okay. So now we have to go back to our header and adjust our structure to provide an ID. And it's a constant. Usually constants have to be initialized when the structure is initialized. So our compiler should complain if we fail to do that. So let's keep going. Let's do ID equals 0. And here our ID is 1. And last but not least, scissors is 2. And now our math should work as it worked before, because we kind of have the same values in there. As you can see, it's kind of the index of the array as well. I can hard code this here, but I could also be smart and say, well, I always return pointers into this items array. So I could also just compare the pointers I get here with the respective member pointer in my static array here. And by that, I could also figure out which ID it has. But if I do it like this, I'm kind of independent of the actual ID or actual member or actual slot the item is in. So if I decide for some reason to change this, my code would still work. So I like that kind of independence, even though it adds more data here. Why not? Let's be explicit. So going back to our little computation, what we would do now is p1 pick .id. Oh look, it's smart enough. If I just hit a dot and it just dereferences the pointer for me. So awesome. That's Qt Creator, by the way. That's not well, that's not expected by any editor. .id. Nice. So that will work. The rest should still be fine. So in theory, if I compile this, it will be something useful will be happening. Okay. So there is still something missing. Oh, that's why it didn't like this line here. I was missing a semicolon. Awesome. Okay, it built. You know, I'm sometimes, when I'm afraid of running the program because it could possibly crash, then I build first. It's kind of a thing of mine, but now I run it and I get a tie. Awesome. So let's go through our little test, manual test. Okay, is this still the right one? Yeah, should be. Okay, that's the long information that I print initially. And then rock, still not rock. That's a tie, rock, paper. Player 2 wins. Paper, rock. Player 1 wins. Awesome. So that's working the same, except that we use structs now. So I'm just committing that intermediate state because it does work and that's something I like. Using structs to represent our game items. Okay. And this time I've got lots of time left, like 20 minutes. That's good. Because now I can use that time to, well, talk about the heap a bit. Maybe I use the heap for fun. Not because it's necessary, but just for insane fun. And, you know, again, I think our program is much more complex than it needs to be. Just imagine the first version that we have that was just main.c and 40 lines or something. Now we have much more code, many more compile units, higher complexity, and didn't win anything really, because RPS, rock, paper, scissors, still is rock, paper, scissors. It's still that simple game that doesn't require us to do much fancy or many fancy things. But let's use the heap. Let's do something insane and let's use the heap. And the only place where I can even imagine using the heap is here. RPS item by name. Right now we just return a pointer to a constant item. So the user cannot change it, which is good because the user is not supposed to change it, as it would break everything. I mean, if he could possibly change the name, that would be allowed, but he shouldn't change the ID. Never. So maybe, okay, it's already enforced because it's a constant here. And what we have here, no, maybe he wants to change the name. Maybe that could be okay, I think, because the name doesn't really matter anymore to the RPS match, right? So what we could allow is we return an adjustable item here, and then the user is able to change the name. It can change the name because it can just you can just set a new pointer here. You know, the pointer is not constant. If the pointer would be declared like this, you couldn't even change the pointer to the name. Nor could you change the characters that the pointer points to. But like this, we are able to change the pointer to the name. And in the previous cases, we work on static objects. You know, we don't even want to allow that, in fact. So we would probably declare like this. But considering that now we just return adjustable items because we allocate this on the heap, do it. How can I tell it to? I think it's it was some key combination that I forgot. Anyway, so now we return an adjustable item because it's on the heap, and then the one who returns this has to deal with deallocating it. And that's the interesting part. Because whenever you allocate something on the heap, you have to deallocate it. So doing anything with the heap makes your program even more complex and makes it, well, even more error prone. So first, let's adjust the rps.c file. Well, to return copies of this thing, right? So we still, it still makes sense to keep these items here statically around because that's kind of our template, our blueprint. And the next thing we want to do is to return copies here. So that is now a pointer to a copy of the item. I kind of like it like this. And then once we find an item, we copy it to some storage on the heap. And I can tell you what's much nicer. Well, it's much nicer to actually leave the allocation of new items to the user. That's so much nicer. Because then, the user can decide if he wants to allocate or wants to keep the memory on the stack or wants to have it on the heap. Okay. So let's do two versions. We have enough time. Let's do one version that does it on the heap, just very bluntly, and that's it. So first, let's get some memory for the item. So it's an RPS item, new item. And in C, we can just assign this. So we say malloc, how much space do we need? Size of RPS item. Okay. That's our new item. That's our uninitialized new item, by the way. It points to memory that has random bytes in it. It's uninitialized. Not even zeros are in there. Not even that. And I could set zeros now, but I don't want it because what I really want is to just bluntly copy one item onto another. And now I'm asking myself where the hell memcopy is defined. I think it's possibly coming in with strings. String.h. Let's see. Yeah, there it is. Maybe there's another header that provides this function to us. And memcopy. Okay. I think it's memcopy, destination, source, and the size of, or the amount of bytes that it's supposed to copy. And what does it return? I think it returns the destination, but I will look that up because I don't know. Yeah, maybe it's okay if I just, maybe Qt Creator can tell me. And no, it can't. So the internet can tell me. Yeah, I should really know this, but honestly, I don't write C so much, or C++. But let's just refresh my memory. Yeah, memcopy, probably that's already it. C++ reference. Destination, source, size of bytes. And what's the return value? Destination is return C. That's what I thought. And it's in string.h. All right. So I was right after all. Does it at some point return a 0 pointer? I don't think so. So I just do it like this. Destination is new item. Source is our item. And the amount of bytes I want to copy is the size of an RPS item. That is it. So now I will have an exact copy. The character pointer has been copied and the integer has been copied as well. And now I return the new item. That's it. That would already work, I can tell you this. So if I run this, I got a tie, and I've got a warning. Implicitly declaring library function malloc with type void unsigned log. Oh, really? No way. Where's malloc? What do I have to see? Which header do I need to get malloc? Please tell me. Enlighten me. stdlib. All right. So this implicit declaration here, wow, that's some C89 stuff, I think. No way. Thanks for warning me. stdlib. Okay, there I got malloc. So now the issue should go away. Interestingly, it worked anyway, right? I built it, and it kind of managed to do that, even though in fact it was kind of a shady situation there. So as I said, whenever you have a malloc, you must have a free. Always. Always. Otherwise you're leaking memory. And even though in this case it doesn't matter at all, it's something you just have to remind yourself. Whenever you do malloc, be sure that you clearly state that this guy was located on the heap and that the caller has to deallocate it using free. That's also important. I mean, we're in a C program, so you would always use free, but it is important for you to know, or for the caller to know. Right now, you know, I'm just saying it, I don't write it down here because, yeah, whatever. So that's important. If we look at main.c, we see that it just passes the pointer, if it's 0 or not, to RPS match, and RPS match just takes these and works with them, but he doesn't deallocate them. And it shouldn't deallocate them because it can't assume that it's his pointers. You know, it doesn't take ownership. If it would want to take ownership of these pointers, you would have to declare that here as well. Warning, takes ownership of the player picks. It will deallocate them. Don't do it. If I would free these pointers here, and if the caller would free them as well, then we have a double free, and your program will crash. So there's no one who prevents this from happening, right? There's no automatic memory or reference counting like in Python. There's no garbage collection like in Go, for instance. There's nothing like that. You do it yourself, and if you fail to do so, things go wrong. So speaking about things go wrong, let's analyze this. Let's analyze this with this program with the Valgrind memory analyzer. Awesome, like this. Let's run it. Oh no, I don't have Valgrind yet. Oh no. See, brew install Valgrind. Brew, come to the rescue. No, Valgrind, like that. Oh. So I do believe that my brew is out of date, or kind of didn't realize that I am on something that is newer than Mavericks. And yeah, we're running out of time. I don't know if that will work in time with the Valgrind, but Valgrind is a memory analyzer, and it will tell you exactly where your program leaks memory, which is a great thing to have. You know, sometimes your program crashes and you don't know why. Because if some memory issues occur, you usually have these occurring at some point in the program, and it crashes much later, at a point that isn't even related to the origin of the issue anymore. And tools like Valgrind make it easy for you, or much easier, say, to figure out what's happening. All right. It updated quite a lot of stuff. Let's see if Valgrind works now. No, I can't install it. That's annoying. I can probably get it to work somehow, but not now. Oh, maybe this. Maybe I can have this something. And then I give up. If that doesn't work, I give up. Ooh. Oh, wait. Actually, that wanted to do something, sorry. All right, apparently that works because Valgrind might be an older version that doesn't yet work on Yosemite. Cool, I think we are getting Valgrind in the last 5 minutes just to see that we are leaking memory. And yeah, all right. Yeah, I would like to show you yeah, it doesn't. Unsupported kernel. Okay, whatever. So it doesn't work. It doesn't work here. That is interesting. I have to look that up because Valgrind is something you definitely want to have if you want to write good C or C++ programs. All right, so let's just cut to the chase here. Valgrind would tell you that you're leaking memory because this guy is allocating memory but not deallocating it. So now in order to get that right, I have to keep the player picks and deallocate them accordingly. So RPS item pointer P1, P2, and I think that P2 will be of type RPS item, and then I will just assign these. Well, I will just type it out because I don't ever trust these kind of double initializations or multi-initializations. Usually it doesn't work for me because, yeah, reasons. RPS item P2, and you can see I don't even care. I don't check if it's 0 or not because that's what RPS match does for me. So here we go, P2, and now all I have to do is pass in my pointers. I do what I do, and what's worse is that, you know, now I actually want to be sure I deallocate my pointers before I return, right? Because otherwise I have a leak. So here I return accordingly, and maybe I don't like that anymore because now it's kind of wrong, you know. It's kind of wrong that RPS match does that, you know. It feels wrong. And maybe it should just say, well, it assumes that these pointers are set. Fine. So this guy has to check now. If P1 is 0, then let's say that P1 is invalid. Like so. If P2 is 0, oops, not 2, that would be bad. Then tell it, oops, tell it that player 1 is, or tell the user that player 1 is invalid. These two cases, you'll just delete them. RPS.h, because we don't need them anymore, it just doesn't happen. Because now we assume that these pointers are set. All right, oops, RPS.c, now we just have to adjust this function here. That gets easier now. But I don't really want to remove this entirely, this check. Let's just put in assertions. In debug mode, at least, we would easily see that a null pointer has been passed, even though we expected a non-null pointer. Okay, like this. That makes the method here much easier. And kind of, now it does what it says it does. It matches these things and tells you who wins. Back to main.c. So we have a leak here too. Just look at this. So if that first pointer is 0, we didn't allocate anything, and we should return. That's fine. So if the player 2 was invalid, now we just return. But player 1 was already located on the heap. So we have to free it here. Don't forget that. Oops. You know, that's how that goes. And there's our memory leak. Quite supple, isn't it? And I think we want to include our std lib as well, so that free is defined. Okay, and And now we do the matching, blah, blah, blah. We always break except for here. And this is something, you know, I mean, look at what I have to do now. I have to be sure that my memory gets freed. Whenever I return, I have to be sure that my memory gets freed. And here I finally return. And this is something I don't like, you know, that I have to put all this, I mean, I have to put the same code here now. And instead of doing this, maybe we just have a return value that is 0 by default. And if something goes wrong, I mean, unexpectedly wrong, and we now know that match doesn't even return that error code anymore. No. So considering that, I could just remove it, and I will. But I can also say my return value here is 255, and then return my return value instead. So I don't have to duplicate that code. Makes sense. That does make sense, but you know, considering that RPS error is not even required anymore, I shouldn't have it. If you don't need it, don't put it in. It's really, it's important. And now all of a sudden our program gets a lot simpler. And I think design-wise, it's actually better than before because we don't mix together so many things. I mean, we had a complex RPS match function. We had a complex RPS match function just so that this one could be easier, so that main could be easier. And thinking about it, if we add new items here and we forget to properly adjust, well, will that happen? It's unlikely that it happens. Let's just stick to assert false, and yeah, I still want to have this RPS error actually. So let's just undo that. Because it is a possibility still, and I would like to be able to signal kind of this weird error. So we'll just keep it like this. Oops. That is not too ugly, and it still kind of shows what we want to do here. So now we have fixed our memory leak and implemented it so that we use the heap. And we use the heap properly. And that's really all there is about a heap, basically, you know. And yeah, our time is over. In case you watched, thanks for watching. Next episode could be the last one with that program. Or I have to think about what else to do because honestly, I'm running out of ideas here. Function pointers could be something, but you know, it doesn't really fill 45 minutes. Maybe it's just a short episode then. Let's see. Okay. Thanks for watching and have a good night.